kids, Shubhamangalam Academical Scholars, myself Sudeep. I'll be taking class 10th for today, okay? And I'll be taking up physics, chapter number 1. We are on page number 12. We need to do the derivation for the mirror formula, okay? I'll mention it over here, chapter 1. That is reflection of light at curved surfaces. We have discussed what were the curved surfaces, what were the terminologies used while drawing the ray diagrams, what rules you need to consider while drawing the ray diagrams. We have studied about concave and convex mirrors and their specifications and where are they used. Right now we need to learn about the mirror equation. The mirror equation will be used in further problems, which is really important. Definitely the derivation needs to just be understood for the sake of understanding the formula. Basically, the formula stands here very important for solving your problems. So let's move on. Okay, can you look at this ray diagram over here? Does it remind you of something that we did in the earlier classes? So look at this one. The object is placed where? Beyond C? Yes or no? When I did the diagram the other day, I used two rules to make one ray diagram. Actually, I specified 3 rules, but what did I say? You can use any 2 of those 3 rules. That day I used rule number 1 and 2. Here we are using rule number 1 and rule number 3. Okay, here the incident light is being projected on the concave mirror and the reflected light passes through the focus. What was the third rule? The undeviated rule. The incident ray passes through the center of curvature and the reflected ray passes through the center of curvature again. Okay, but in figure number 12 of your book, where we actually study about the beyond C object condition, they have also used rule number 1 and 2 like I did that the other day. So what does this show? That you can use any of those 2 rules. Okay, in figure number 12, they are using rule number 1 and rule number 2. In figure number 21, they are using rule number 1 and 3 for the same object position. What is the object position? Object is placed beyond C. I'm sorry. Okay. So now let's go on to the derivation class. Here you need to consider triangle ABC and triangle A-B-C. Okay, you need to understand something over here. This is the object, okay, and the rays are emerging from the tip of the object. There are 2 incident rays. The first incident ray is parallel to the principal axis and the reflected ray passes through the focus. The second incident ray passes through the center of curvature and the reflected ray also goes in the same direction. Both of them intersect and there is an image formed which is upside down. It's upside down means what are the other characteristics of this particular image? It is real, inverted, and can you see the size over here? It is diminished. It is lesser than the size of the original object. Now we have also named, okay, the specifications of the image. Now you need to look at this. Consider triangle ABC. Can you see triangle A, B and C? Yes or no, class? And then you have triangle A dash, B dash and C. Triangle A dash, B dash and C. This triangle and this triangle, this big triangle that you see over here and this tiny triangle that you see over here. Both of them are representing similar triangles. So as per similar triangle property, AB by A dash B dash is equal to AC by A dash C. Okay, this is our equation number 1. Now, look at further 2 triangles over here that we have made. Look at P dash XF. Can you see this triangle over here? P dash XF. What is the other triangle we need to consider? A dash B dash F. The other triangle is A dash B dash F. So we are going to consider this triangle as well as this tiny triangle along with it. So similarly, because of the similar triangle property, it is going to be P dash X by A dash B dash is equal to P dash F by A dash F. Did you understand till here? What did we do? We just considered 2 triangles respectively, and because of the similar triangle property, we formed 2 equations. This is equation 1 and equation 2. Now you need to look at this. Okay, you can see P dash X and AB are of the similar height. Do you understand? P dash X and AB are of the similar height. So we can write AB is equal to P dash X. So in my second equation, I can replace P dash X as AB. Did you understand now? So taking the second equation, so I have over here, sorry, AB by A dash B dash is equal to P dash F by A dash F. Okay, what did I do? I took the equation number 2 and I replaced P dash X as AB, because both P dash X and AB are equal in height. So I equated them and I replaced P dash X as AB in my second equation. Okay, I'll write it over here. This is the second equation which was taken and it was renewed by replacing P dash X as AB, and this becomes my third equation. Fine with everybody over here? Now look at this. Compare equation 1 and equation 3. Can you see that the LHS of both the equations are the same over here? So what did I do? I am taking equation 1 and equation 3 and I'm comparing them. Okay, once I compare them, what do I conclude? That the LHS of these two equations is absolutely the same. If LHS is the same, the RHS can be equated. So what do? I write AC by A dash C is equal to P dash F by A dash F. Did you follow this one? Why did I do this and how did I do this? I considered which and which equation? I considered equation number 1 and equation number 3. And when I compared them, I noticed that both the LHS of these two equations is the same. So if LHS is the same, the RHS could be equated. That's what I did. I took the RHS component of the first equation and the RHS part of the third equation and equated it. Okay, now I need to understand a notion over here. You need to understand what are paraxial rays. Okay, paraxial. Don't you think it is made by combining two, like a portmanteau of two terms, like, paraxial, parallel and axial? What do you mean by this? Something that is parallel to the axis. What is the axis over here? The principal axis, of course. So we are talking about this particular ray which is parallel to the principal axis. So they have given us a condition: if this parallel ray which is quite away from the principal axis, but it is still parallel, okay, it is quite away from the principal axis, if this particular parallel incident ray was very close to the pole or very close to the principal axis, then P could be equal to P dash. Did you understand now? What did I say? We are talking about paraxial rays. How does the word paraxial come? Parallel and axial. What is parallel and axial over here? It is nothing but this particular incident ray which is parallel to the principal axis. So what is the condition that we are taking under approximation over here? It is nothing but if this particular parallel incident ray was very close to the principal axis, then P would be equal to P1 or P dash. Okay with everybody? Fine. If this particular parallel incident ray was very close to the principal axis, or if it was a paraxial ray, then P would be equal to P dash. So what is our next approximation over here? That P is equal to P dash. If P is equal to P dash, what is the change in this particular equation 4 over here? It is AC by A dash C is equal to PF by A dash F. Okay with everybody now? Did you understand why did I equate P to P dash over here? Because I was considering the terminology of I was considering the approximation of paraxial rays. And what are paraxial rays? When the parallel ray which is parallel to when the ray which is parallel to the principal axis is very close to the principal axis, that particular ray is called as paraxial ray. And in this condition, P will be equal to P dash. Okay with everyone now? So yes. Now, we need to understand further steps. AC. Can you see AC over here? Is there a different form of writing AC? Consider PA. PA minus what else? PA minus PC can be written as AC. Yes or no? Did you understand the step, or should I write it much more neatly over here? Okay, wait for a second. Yes. Of course, I don't know whether you are understanding or you can give me a reply. But yes, look at this one. So there needs to be a certain form of writing all these components of this particular equation over here, which we have formed now. Okay, now look at this. AC can be written as, this is AC. AC can be written as PA minus PC. PA minus PC. Okay, what are the further ones over here? A dash C. Can you see A dash C over here? How can I write A dash C? PC minus PA dash. A dash C is equal to PC minus PA dash. Can you see that over here? I consider PC minus PA dash. That gives me A dash C. Okay with everyone? X like 3 minus 2 is equal to 1. It just means that. You need to just focus whatever I'm writing over here. Okay, now the next one, A dash F. Can you see A dash F over here? How can I write A dash F? It is nothing but A dash F can be written as PA dash minus PF. PA dash minus PF. Okay, okay with everybody now? Now you need to understand from before or from the previous videos and all, what will be the value of PF? PF is nothing but the distance between the pole and the focal point. The distance between the pole and the focal point is nothing but the focal length. So PF is equal to F. Okay, look at PC. The distance between the pole and the center of curvature is nothing but the radius of curvature. What is the relation between the radius and the focal length? R is equal to 2F. So the value of PC is going to be 2F. What else do we have over here? We have PA. Can you see PA over here? And at AB is the object. At A, you are placing your object. The distance between the pole and the object is called as object distance. And how do I denote object distance in my derivation now? I denote it with small u or the lowercase u. Okay. What is PA over here, class? It is the object distance. So where is the image distance? At A dash, the image is being formed. So PA dash is my image distance. So I write it over here, PA dash is equal to V. Okay, you need to understand this part. Now these equations need to be substituted in equation number 5. In place of AC, I am going to write PA minus PC divided by, what am I going to write in place of A dash C over here? I'm going to write PC minus PA dash is equal to, PF remains the same, and then I have A dash F. How do I write A dash F? I write it as PA dash minus PF. Okay with everybody over here? Please excuse me for this. I'll just drop it. And okay, here we are. Fine, class. So now I have substituted the values. I have substituted these values in these. Okay, and I have a big equation over here. I have the values for individually of all these components also. What is PA, class? It is U. That is my object distance minus PC. What is PC? The radius. How do I write the radius in terms of F? R is equal to 2F. Remember that? Twice the focal length is equal to radius of curvature. So I'm going to write U minus 2F divided by, what is PC again? It is 2F minus, what is PA dash? It is V is equal to, PF can be written as F, which is nothing but the focal length. PA dash is again my image distance, and PF is again my focal length. Okay with everybody over here? Did you understand how did I substitute these values? I've already written it for you over here. You got to know what is PF, PC and PA and PA dash mean. It is nothing but the focal length, the radius, the object distance and the image distance respectively. So I substituted them over here. Now what do I do with this? Just leave them over here? No. I'm going to cross multiply. Okay, so now U minus 2F into V minus F is equal to F into 2F minus V. Okay, so over here class, cross multiply them. What do you get? UV minus UF minus 2FV. Did you understand? And plus 2F into 2F, 2F into F, how much? 2F square is equal to 2F square minus 2V. Okay, wait. Minus VF. Okay, you're just going to cross multiply. I definitely believe that you know how to cross multiply them. So now you have 2F square on both the sides. So I can just cancel them. Even if I take this that side, it is going to be minus and it gets cancelled. So I directly do it. And then I have UV minus UF. If I take 2VF that side, what do I get? I get VF. Okay, UV is over here and I take UF that side. So what do I get? I get UF plus VF. Can you look at this equation over here? How did I get this? I solved all these and I got this. What did I do? I cancelled 2F square on both the sides and I took 2VF over there. If I take 2VF over there, minus 2VF becomes plus 2VF. So plus 2VF and minus VF gives you VF. That is what I got on the RHS side. What was left out? Minus UF. I take UF also that side. Minus turns into positive. There are just two more steps to go. Okay. And I will do it over here. Fine class. So yes. So you are going to take this equation and place it over here. It is UV is equal to UF plus VF. Dividing this entire equation, dividing by UVF. Okay, UV by UVF is equal to UF by UVF plus VF by UVF. Okay, UV and UV gets cancelled. UF gets cancelled. VF gets cancelled. What is left out? 1 by F is equal to 1 by V plus 1 by U. Can you see? This is your mirror formula equation. Did you understand now? This is the equation that you will be using for solving further problems. I hope you understood step by step. Please replay the video to go for every step that we have done. How did we reach till here? And after this is pretty easy. You are just dividing the entire equation by UVF. Okay, and then you get the final equation over here. That's the mirror formula. Thank you. So class, we are going to study about the sign convention right now. Okay, the object distance will be denoted as U. The image distance will be denoted as V. The focal length will be denoted as F. Okay, so now the height of the image is HI and height of the object is HO. Radius is denoted as R and all these things. So you need to give a certain sign to all of them, like positive or negative, depending upon how are they placed. For example, okay, if this is the concave mirror and this is where my object is being placed and this is the pole, all the distances should be measured from the pole. Okay, that is your first rule. All the distances should be measured from the pole. Now, if I draw the first incident light which is striking the concave mirror from the object to the mirror over here, I need to calculate the object distance. So anything that goes against the incident light will be taken as negative. How do I write the object distance as U? And what sign am I going to give it to this? Minus. Why am I giving it as minus U? Because I am going against the incident light. Can you see the incident light coming from A and B over here? Okay, from the tip of AB, and striking the concave mirror. How do I write object distance as u? What is the sign I'm going to give it over here? Plus or minus? I'm going to give it as minus because I am measuring the object distance from the pole to the object. While measuring the object distance from the pole to the object, I am going against the incident light. Any measurements which are going against the incident light will be given the negative sign. Did you understand here now? Okay. Object distance is minus in this case. So, finally, now look at the image. This is the image that is formed. It is A dash and B dash. The image formed over here. I want to calculate the image distance. How do I write image distance as? I write it as V. Okay. What is the sign I am going to give it to image distance? Image distance is also formed on this side only. And I am going to measure it from the pole. Okay, all distances should be measured from the pole class. The object distance is also measured from the pole, and similarly, the image distance should also be measured from the pole. So while I am measuring the image distance from the pole, I am again going in the opposite direction of the incident light. The incident light is in this direction and I am going in this direction while measuring from the pole. So the image distance is also going to be negative in this case. Okay with everyone? Now look at PF. What is PF? The focal length, denoted as F. This is also measured from the pole and we are again going in the opposite direction of the incident light. We are going against the incident light. So the focal length is also minus over here in this case. Look at the height of the object. It is upright and it is above the principal axis. Anything above the principal axis will be considered as positive. So the height of the object over here is positive. Why is it positive? Because it is upright and above the principal axis. Anything below the principal axis will be considered negative. Now what is the height of the image over here? It is negative because it is inverted. Did you understand? And it is below the principal axis. We will recollect this. A simple diagram drawn over here that is beyond C. It is explaining you that it is beyond C. Okay. Fine. So now what did I do? I placed an object over here and the first ray was striking. What is this ray? The incident ray. The reflected ray passes through the focus. Fine class. I need to measure the object distance. From where do I need to start? I need to start from the pole. Okay, that is my first rule. All distances are measured from the pole. Now, as per the second rule, anything that goes against the incident light, any measurement that goes against the incident light is taken as negative. Okay, now I want to measure my object distance. What do I consider object distance as u? And I start measuring it from the pole. When I am measuring it from the pole, am I going in the direction of the incident light or am I going against the direction of incident light? I'm going against. When I'm going against, what sign am I going to give it to object? I'm going to give it minus u. Similarly, my image is formed on this side again and I want to measure the image distance. Again, I need to start from where? Should I start from here or from the pole? I need to start from the pole. When I start measuring the image distance, I understand that I'm going against the incident light again. So that is why the image distance is also going to be negative. Look at the focal length. Again measured from the pole. So that is why the focal length is also negative in this case. Now let's consider the height of the image and the height of the object. Height of the object is positive because it is upright and above the principal axis. So it has a sign plus and I write it as plus h naught or ho. Next, what about the image? Height of the image? It is negative because it is inverted and it is below the principal axis. Anything below the principal axis will be given the sign negative. This is what is called as sign convention. Definitely the signs are going to reverse when you consider the convex mirror. This is a concave mirror, right? All the signs are going to reverse when you consider the convex mirror. Fine. So now let's come to some other topic over here known as magnification. Fine. They have asked us to consider two triangles over here. Again, it is POO dash and PII dash. When I consider these two triangles, I can write as per similar triangle property, II dash by OO dash is equal to PI by PO. Fine. Now II dash is nothing but the height of the image. The height of the image is below the principal axis. So how do I write it as minus HI? Very good. Okay with everybody, I hope you have understood why we have written minus HI over here. II dash is nothing but representing the height of my image in the diagram. Now how does the height of the image can be written as what? HI. And what sign am I going to give it to? I'm going to give it the negative sign because it is below the principal axis. What about the object height over here? It is above the principal axis. And how do I denote it? HO. Do I write minus over here? No, because it is upright. So the sign is positive. Just leave it like that. What is PI class? P to I is nothing but the image distance. When I'm measuring the image distance from the pole, I am going against the incident light. What is the incident light? It is in this direction. How am I going? I am going in this direction. This means I'm going against the incident light. So I write PI as minus V because that is how you represent image distance. And what is the sign I gave it? Because I gave it minus. Why did I give minus? Because I'm going against the incident light. What about PO over here? From the distance between P and O is nothing but the object distance class. How do I write it as U? What am I missing? The sign. What sign am I going to write? Plus or minus? I'm going to write minus again because I'm going against the direction of incident light. This is the direction of incident light and I'm measuring from pole to the object. So I write minus U. Okay with everyone? Okay. HI by H naught. This minus can be transferred over here and minus of minus V by minus U. Minus and minus will get cancelled. So what is the final equation you are going to get? HI by H naught is equal to minus V by U. Okay. So this is what we get. Fine. This minus is actually for the entire symbol over here. I'll write it much more clearly. Minus for the entire fraction over here. HI by H naught is equal to minus V by U. What does this mean, class? It means height of the image by height of the object is equal to minus image distance by object distance. That is how we do the magnification. Now, why do you need to know the magnification? Only because to know the characteristics and the other nature of the image. Okay, you can see the terminologies being used over here. It is height of the image, height of the object, the image distance and the object distance. When you consider all of this, you will come to know what is the resultant size of the image, how does it look, whether it is real, inverted, erect, upright, or diminished, enlarged, or same size. All this you will come to know when you are using the magnification formula. Only once we do a problem you will understand. The next is the problem. Fine. So I want you people to open up your 10th class textbook, of course your class textbook, and open up to page number 14. Okay, and in the bottom you have the example question, and I will read out the question for you. I want you to look into your textbooks and open up to page number 14 while I'm reading the question. You can pause the video and remove the textbook and open it up. Please do that. Let's do this problem together. I definitely know half of you must not be opening the textbook right now. So please open up the textbook and turn to page number 14 so that I read the problem and you understand what am I reading. An object 4 centimeter in size. This means they have given us the height of the object, which is nothing but 4 centimeters. 4 centimeters in size. Okay, what does it mean? If this is the concave mirror and this is the object, the height of the object is nothing but 4 centimeters. That's the size. Fine. An object 4 centimeter in size is placed at 25 centimeter in front of a concave mirror. If this is the concave mirror and the object is placed at 25 centimeters, This means 25 centimeters is nothing but my object distance. Okay, now you need to consider the signs also. I will tell you what is the sign. In front of a concave mirror of focal length 15 centimeters. Where do I write focal point? Over here. So P to F is nothing but 15 centimeters. It is P over here and it is AB over here. Okay, now at what distance from the mirror would a screen be placed in order to obtain a sharp image? Basically, what are they asking you? They are asking you what is the image distance. Only at a certain distance you can place the screen so that you get the image. This means what are they asking you? They are asking you where is the image formed? At what distance is the image formed? At what distance is the image formed is nothing but what do you need to find out? You need to find out the image distance. Okay, class. There we go. I'll explain you what all do we have with us. We have the height of the object, we have the object distance, we have the focal length, and we need to find out the image distance. Now you need to consider the sign conventions. Okay, now look at height of the object. It is 4 centimeters given in the question. Am I going to consider it as negative? I am not going to consider it as negative because it is upright and it is above the principal axis. Anything above the principal axis for heights, what do? We consider positive. Now look at the object distance. Object distance is given as 25 centimeters. What did they say? They placed an object at 25 centimeters in front of the concave mirror. What does the 25 centimeter denote? It denotes object distance. So now object distance is 25 centimeters and we need to measure the object distance from the pole. When you measure the object distance from the pole, you are going against the incident light. When you are going against the incident light, the object distance will be written as minus 25 centimeters. The same thing happens for the focal length also. When you are measuring the focal length, you are measuring it from the pole to the focal point. And this means you are again going against the incident light. So whenever you go against the incident light, the focal length here is also minus 15 centimeters. What if they ask where to place the screen? What is the use of the screen? To get the image. Yes or no? So what does this mean? Where do I place the screen? At a certain distance. What is that distance called as? Nothing but image distance. Because what am I getting on the screen? I'm getting the image on the screen. So V is equal to question mark. So what formula am I going to use? 1 by F is equal to 1 by V plus 1 by U. You can interchange them also because it is just plus sign. Okay. So 1 by F. What do I write 1 by F? 1 by minus 15 is equal to 1 by V. You need to find out what is V. So write V as it is. And what is U given as? 1 by minus 25. I bring 1 by minus 25 on this side. Okay. Don't interchange and keep doing whatever you want to. Just focus. What am I telling? What did I do? This was my first statement. Okay. 1 by F is equal to 1 by V plus 1 by U. F is written as minus 15. V will be written as it is. U is written as minus 25. Now I take this particular fraction on this side. What do I write it as? 1 by 25. Minus 25 turns into what? Plus? No. So minus 1 by 25 becomes plus 1 by 25 and the minus 1 by 15 from the previous one is equal to 1 by V. I just took this part to the LHS. That's it. Nothing else. Now let's try to solve it. What do we have over here? Can you see this? So it is 15 minus 25 by 25 into 15. Okay, this is how I solve fractions. You can do it your mathematical way also, like whatever you regularly follow and consistently do it. If you're getting confused in it, basically there is an easy trick. Can you see the numerators to be equal? Just put the denominators across and multiply the denominators over here. Okay, do you understand? 1 by 25 minus 1 by 15. What is missing over here? Put 15 over here, put 25 over here and divide it by 25 into 15. Okay, put the opposite denominators in the numerators place and multiply the denominators. That's an easy technique. Again, look at this. 1 by 25 minus 1 by 15. How do I solve it? I just wrote it as 15 minus 25 divided by 25 into 15. There we go. Then we have is equal to 1 by V. What is 15 minus 25, class? Come on. It is minus 10 by 25 into 15 is equal to 1 by V. I hope I'm going correct. Okay, now 5 twos are 10, 5 fives are 25. What is 15 into 5? 15 into 5 is approximately 75. Yes. Okay, minus 2 by 75 is equal to 1 by V. Fine. So now what do we have the equation as? We have minus 2 by 75 is equal to 1 by V. Can I take a reciprocal? Of course I can take a reciprocal. So V is equal to minus 2 by 75. Interchange them. V is equal to minus 2 by, sorry, again, just a minute. Okay, here we go. Switch it on. Here we are taking minus 75 by 2 because we took a reciprocal. So now what is 75 by 2? 2 ones are, 2 threes are 6. Okay, 2 sevens are 14.5. That gives me an approximately minus 37.5 centimeters is equal to V. How did I do this? You need to know this. Okay, fine. Look at this. 75 divided by 2. Okay, 2 threes are 6. Carried over. 2 sevens are 14.1. 2 fives are 10. Okay, this is what we did, the division. Okay, so what did we get the image distance as? 37.5 centimeters. What does this show me? That the image is formed at a distance of 37.5 centimeters on the principal axis, and it is below, and it is measured from the pole. That is why it is taken as negative. Okay, so now we need to understand what is the magnification. Fine class. So we have one more formula to understand the nature of the image. Hi by h naught is equal to minus v by u. Hi you need to find out. Ho is already given. What is Ho? It is 4 centimeters. Hi by 4 is equal to minus. What is the image distance given as? Minus 37.5. Okay, image distance is given as minus 37.5. This minus will be written separately because it comes from the formula. V value alone, it is 37.5 centimeters. Now, divided by U. What is the U value? It is minus 25 centimeters. It is minus 25. Can I cancel one of these minuses over here? So what do I have? Hi is equal to 37.5 centimeters into 4 divided by 25. Can you see this now? I'll just rub this portion. Okay, now look at this again. Hi by 4 is equal to Hi by h naught is equal to minus v by u. What did I write in place of v over here? Minus 37.5. What did I write in place of the object distance over here? It was given in the question as minus 25. Okay, so now when I replace them, I'm cancelling one of the minuses. I have minus 37.5 over here. Let me put the minus over here. Let me copy this over here so that you can, understand what am I writing. Minus 37.5 into 4 divided by 25. Fine. 5 5s are 25. 5 7s are 35. 36, 37. 5 5s are 25. 5 1s are 5. 5 1s are 5. 6 7. 5 5s are 25. 15 into 4 is how much, class? It's 60. Okay, so it is minus 6 point, there is a point also over here, no? 6.0 Hi. Can you see that? Yes or no? So what is the height of the image given over here? It is minus 6.0. Okay with everybody? And it is centimeters. Did you understand? Now, what did we get the image distance as? Minus 37.5 centimeters. That is what they asked us. What is the other value we got? We got the height of the image as minus 6 centimeters. What was the height of the object given as? It was given as 4. If the height of the object was 4 and the resultant image that you got is 6, this means the image is larger when compared to the object. Yes or no? So what is the nature of the image over here? It is enlarged. Why do I say it is enlarged? Because 6 is greater than 4. Don't look at the minus over here. I'll tell you why is the minus. What is the significance of minus? Look at just the numbers. 6 and 4. The height of the object was 4. Height of the image is 6. 6 is definitely greater than 4. This shows me that the image is enlarged. and it is larger when compared to the object. Now let's look at the minus. What does the minus show? When do I write height of the image as minus? When the image is formed below the principal axis. Did you understand? This means that the image is formed below the principal axis. If the image is formed below the principal axis, what kind of image it is? It is upside down. What is an upside down image called as? Real and inverted. Okay, that is the significance of minus over here. That minus here tells you whether the image is real and inverted. Okay, if it was plus over here, this means it would be erect and virtual, upright. Okay, if it was plus 6 centimeters, it would be enlarged, erect and virtual. But what is it? It is minus 6 centimeters. What does minus represent for HI? This means the image is formed below the principal axis. If the image is formed below the principal axis, this means it is inverted. What are inverted images? Real images, class. So what does the minus show? That the image is real and inverted. So these are the characteristics we have jotted down by observing the resultant height and the image distances that we found over here. Okay, what was the resultant height of the image that we got from the problem? It is minus 6 centimeters. 6 greater than 4, showing me that the image is enlarged. Okay, just the number when you want to check whether it's enlarged or diminished. Did you understand? When you want to check whether the resultant image is enlarged or diminished or the same size, you are just going to check the number. Now I want to know whether it is real or virtual. How do I know whether it is real or virtual? Consider the sign. If the sign was plus, it would be virtual because virtual images are upright. What do I mean by upright? Straight, yeah, above the principal axis. Okay, now but I have a minus over here. What does the minus mean? That the image is inverted and it is upside down. Only real images can be upside down or inverted. So that is why I write these 3 characteristics over here. This particular problem has been repeated in many of the question papers. The question paper guy usually gives the sum only and sometimes just changes the numbers. That's it. If you know the format, you know how to solve the mirror equations. In this particular problem, you will know. Okay, basically what were the 2 things you had to find out? The image distance and the height of the image. The next is a very small topic, Archimedes' principle of burning ships and how to use the concave mirror and by using a dish antenna. Okay, those are very small topics. We will do them now. So now we are going to learn how did Archimedes. I hope you have read his name in earlier books, physics books or earlier science books. He was a Greek philosopher, the Eureka guy. Yeah. So here Archimedes was a Greek philosopher and he discovered, he found out a very easy way of winning over a team or over a range of army which was much much stronger than them. It was basically Greeks versus the Romans. Okay, and the Romans had a really huge army with all the cannons and all the machinery that you require for the war. But the Greeks were lesser in number and they did not have such good machinery, but they had brains. You can see this man over here. So what did he do? So he placed a concave mirror at a certain position where the sun's rays could be directed towards it. Okay, and whenever the ships of the Romans were approaching their country, okay, whenever the ships of the Romans were approaching them, what happened? As they were coming closer, because of the reflection of the mirror over here, the reflection of light. How did the reflection of light happen? This is the concave mirror and you have the sun's rays being directed towards the concave mirror. Those are nothing but the incident rays. So at a certain point they get reflected also. As they got reflected, on the flagpole they had certain paper like thing being attached to the flagpole. Yes or no? Paper burns when you place it at a certain position, like the magnifying glass. Okay, for example, if I take a magnifying glass and I place a paper and there is sun over here, huge sunlight, because of the sun's rays, the paper is going to burn. Okay, you can focus the magnifying glass on the paper and with the help of the sun rays, you can burn the paper. Okay, similarly we have also done in this lesson only. Okay, so if you have the rays coming from infinity and they are going to meet at a particular focal point, anything that I place on the focal point is going to catch fire, or it is going to show you the light. Okay, so here what happens was, as these ships were approaching further and they were coming closer, the concave mirror reflected the sun's light, and the paper which was attached to the flagpole got burnt. Okay, it caught fire. So as the paper of the flagpole caught fire, definitely the entire ship also got burnt. Similarly, in this way he was able to burn innumerable ships, and Greeks won the war, which was Greeks versus Romans, even though they were lesser in number and they had lesser machinery, lesser arms, lesser people, but still, because of using quite good brains and quite good intelligence, you having a scientific mind really helps you. You can see what did he do with just the placement of few mirrors, or he just placed, with the placement of a particular mirror, the concave mirror, he placed it in a certain position so that the sun's rays could be reflected back, and they could burn the paper part of the ships, which could lead to burning of the entire ship. Now we have to consider something else over here: how to make a solar cooker. How do you make a solar cooker? For this, you need to consider the TV dish antenna. You must be having the TV dish antenna at the terrace of your house. So it is basically like this, the internal portion, and there is a pole-like thing in the middle. Okay, yes or no? So what am I going to do? I'm going to take a big acrylic sheet and I'm going to cut into isosceles triangles. Okay, so that the height of the isosceles triangles equal to the radius of this dish antenna. Fine, and I'm going to stick those isosceles triangle acrylic sheets onto the antenna, somewhat like this, so that the base of the isosceles triangle touches the circumference of the antenna. Cut some 8 to 10, 8 to 12 pieces, so that it becomes, the entire dish antenna circumference is covered. Okay, remember you have a pole here in the middle. Fine. Now, at the end of this particular pole, you're going to place the vessel where you have the rice and water. Fine. This particular point is nothing but the focal point. Fine. So now, once the sun's rays are directed on this dish antenna, because of the nature of the acrylic sheets, the incident rays are going to get reflected, and they are going to meet at the focal point. So at the focal point will act like a Bunsen burner. Usually what do you do? How do you boil rice? Okay, what do? You just place a vessel, you place rice and water in it and place it on the Bunsen burner and switch on the gas. Okay, here you're not doing anything of that sort. You just took an antenna and you have pasted acrylic sheets inside the antenna when you have cut them into isosceles triangle shape, so that the height of the isosceles triangle is same as the radius of the dish antenna over here, and at a certain position where all the sun rays were meeting, you placed your rice and water vessel. After some time you will see that the rice is cooked. Why was it cooked? Because the rays of the sun were directed towards the dish antenna, and because of the shape, which is nothing but the parabolic shape. Okay, it is like a parabola. Yes or no? The shape of the dish antenna is like a parabola. Because of the shape over here, because of the parabolic shape of the dish antenna, the rays, the incident rays, were meeting at a certain point called as the focus, and you placed your rice and water vessel at the focus. So there was lots of amount of heat over there, which helped in the cooking of rice. So there we go. That is how you make your solar cooker. So just to recollect, what are the uses of concave and convex? Fine. Convex used in rear view. Concave used in shaving mirrors. So because it is going to give you a larger image of this tiny hair on your skin, and then it is also used by the dentist so that he can have a larger view of your tooth or teeth. And then convex mirrors, also those mirrors, the rear view mirror is one thing, also the car view mirror, where you are going to see a diminished view of the object that is behind you. Okay, and then what else do we use in concave? As the headlights, of course. The headlights of the vehicles are nothing but concave in shape. That is why they're giving you broader light. The bulb is really tiny, but it gives you really broader light, so that when you travel in the night, you have a broader view at a broader angle, and you can see the vehicles in front of you. Okay, oh, that was it for all. Pretty easy. I hope you understood the chapter. It was about reflection of light at curved surfaces. The curved surfaces were nothing but the spherical mirrors. What were the two kinds of spherical mirrors? Concave and convex. We studied few rules regarding both of them, 3 and 3. 3 rules for concave and 3 rules for convex. We studied how to do ray diagrams. We studied what is a converging mirror and what is a diverging mirror. The concave mirror is converging and the convex mirror is diverging. Remember that. We have a very good table on page number 17 that I want you to, study. Please write down Sakshi. The classwork is chapter 1 done, and the homework is study the table on page 17. I have given you the relative ray diagrams also of this table. So I want you to maintain a physics classwork, which we have done earlier also when we were studying in 9th and we were studying the 10th portion. I hope you have a physics classwork with you. You're going to write down whatever is there in the table, copy the exact table from page number 17 in your classworks, and draw the respective ray diagrams for each of those details over there. There's some 5 to 6, so you need to draw some 5 to 6 ray diagrams with respect to each of the entry that is made in the table. Okay, we have done those ray diagrams also in the previous video. If you want any further information, you can definitely look at the before video again. Okay, the solar cooker is very important for 2 marks. Please put a star mark in your textbook. And then the Archimedes usually is also coming in, objective type questions, like what kind of mirror was Archimedes using. And the uses of concave and convex is also again for 2 marks. And the ray diagram question, okay, the ray diagram question is actually for 4 marks. Very, very important question, very important. So you need to understand, learn the table, study the table properly, study the ray diagrams properly. What else is important for 4 marks is the problems regarding the mirror equations. You remember, not the derivation, the problem that we did regarding the mirror equation on page number 14. I guess we have the problem. Yes, we have the problem on page number 14. Okay, the object distance being 25 centimeter one. We have just one example problem in the entire chapter. So problems like those are very, very important for 4 marks. So that's all, I guess. Yes, we are done with this. Hope we start the next chapter soon. Thank you.